So, a few weeks ago, I posted a video where I basically no-clipped a piece of metal into another piece of metal by mistake, and I thought I figured out what happened, but this comment right here made me question my theory, and I realized I left out a crucial variable: solder. Meanwhile, on Instagram, I had uploaded the same video there, and Mark Nelson, who is a very experienced jeweler and teacher, commented something to the same effect and suggested that this may have to do with the zinc content of the solder bonding with the zinc of the brass alloy and lowering the melting point of said brass in those areas. This has made me doubt my original conclusion, and so I feel like I need to get to the bottom of this. So I went through my records from when I taught that university class where I made this unique little anomaly, and I found the itemized budget request form that I had submitted. Now, I tracked down the manufacturer who made the solder for that class, and I found their MSDS form on their website. And sure enough, look at all that zinc. Now, the brass that I like using personally has a lot of zinc in it, 30% in fact. That's double the amount of zinc in more popular alloys such as this one right here. I also tracked down the same flux, the same bezel wire, and verified that the thickness of the metal was 0.8 millimeters thick, or 20 gauge in freedom units. So with all these variables accounted for, I figured it was time to do some experiments.
Experiment 1.
An experiment was carried out to see if I could repeat this effect without solder. If it really was just one metal reaching the solidus state faster than the other metal like I had originally thought, then the solder shouldn't be a factor. Flux is added to the top plate, and the whole thing is heated from below with an atmospheric torch. As the flux heats up, it froths and bubbles, and then turns into this glassy sludge. This is expected behavior from this kind of flux. It takes a bit of time, but eventually the brass reaches the solidus stage and the fine silver passes through, but not by a lot, and only after the fine silver gets so hot that it melted quite a bit. I wondered if maybe the backside was getting too oxidized for the metal to pass through properly, so I went ahead and repeated the experiment, but I fluxed both sides this time. The results were about the same, but a little more of the silver came through on the other side this time.
Experiment 2.
An experiment was carried out to see what would happen when we add solder to the equation. We're going to use wire solder that's been cut into little sausages, and yes, that is a technical term. Now, anyone who's done a lot of silversmithing will recognize that this quantity of solder is generally referred to as too much solder. Anyway, we repeat the experiment, and the flux decides to be obstinate and the solder sticks to my pick. But eventually, everything gets in order, and well, that worked a lot better, though the amount of solder did make the back quite messy. I'm noticing that the fine silver pools when it gets hot, and the amount of pooling on the backside is less than desirable. So let's try something else. This time I'm using bezel wire that is 1 millimeter taller, and I'm using a much more reasonable amount of solder, just enough so that it will wick into that seam and hopefully lower the melting point along that edge. Flux has been applied to both sides, and the camera is lowered to get a better view of the anomaly. The silver is heated, and the paste flux misbehaves like it normally does. I keep heating, and the critical moment where the silver passes right through the brass occurs. Let's watch that again. Pay close attention to the left side of the sheet. Now we're thinking with portals. So there we have it. I'm fairly confident that I was mostly correct the first time, however adding solder to the mix will dramatically improve the effect. Reviewing this footage also made me realize that 0.8 millimeters is a lot of material for the bezel wire to pass through, so perhaps the fine silver in the other samples that I have got stuck somewhere along the way. I'm not certain. Either way, I don't believe that it's quantum tunneling as many of you have suggested, seriously or otherwise. The only other conclusion that we can glean from this experiment is that
Sulfur is not attracted to magnets. Write that down.